So Unit 1 Energy for Learning Target 4 says when matter with kinetic energy comes in contact with a second set of matter, energy is transferred resulting in friction. And the most important thing to remember is that friction is equal to heat. So once we know that, if I place this here, it might not have, it has to have kinetic energy. So because it's not moving, it's not going to have kinetic energy. Once I start to move it, it increases heat. There's three, so that's friction because it's two objects and one has kinetic energy. It's going to make it have friction, which is the molecules are going to move faster. So three things are going to increase friction, and it all happens because you increase kinetic energy. One, more force down, so more mass down. So if I push on this down, that will make it have more heat versus a light one. A rougher surface because it has more places to catch, and a fast movement. So this one does a really good job making a fast movement. So because we had an increase in movement, kinetic energy, it increased the temperature and the molecules inside of the objects moved faster. You can see it in different forms. So this is a person that is going to be powering a bike, and we better get the energy symbols. So she has chemical energy in her body. As she moves, it transfers into mechanical energy, and some heat is given off because there's two surfaces here. So because there's some surface friction here, you get some heat. That mechanical will turn into electrical, and that electrical will come into contact with another surface again and create heat, and in this case, light. So everything is going to create, if two objects are together, everything that has two objects coming into contact is going to create heat or friction. So let me show you that in the skate park one. So here's a person. If we place them here and we let them go, notice that this person does not go up to the same height that they were before because they have friction. So friction is what's slowing them down because the surface of the wheels and the surface of the ramp are interacting and heating up the wheels and the course. If I have no friction, in a world without friction, all the potential would become kinetic, and all that next potential would become kinetic potential, and so on, that he would never slow down. In a world without friction, he'd never slow down because there's no heat transfer, so all of the kinetic can become all of the potential. Once you add in friction, you can see that more friction is going to slow him down faster than less friction. So the other thing to go on, the more force downward, more mass. So if we make this a larger kid, he's going to actually slow down more than if he's small. So see how he's slowing down here? You can see the thermal creep up. That's the friction we were talking about. If I make him small, he's going to transfer friction, but maybe not as quickly because he doesn't have as much mass going down, so the heat transfer is a little bit slower. So one more example of friction, done that one, is the pendulum, and we saw this on Learning Target 3. So in this system, I'm increasing potential energy, and if I give it no friction, it will always return to that same spot. All of the potential will become all of the kinetic over here. As soon as I add friction into our system, you can see that the heat starts to increase, and that slowly this is not going back to the same height that it used to be, and it will slow down over time. If you have lots of friction, then it has more contact with the air, so it's like heavier air, heavier or more contact up here on the string, and it will turn into heat quicker than with less friction. So yeah, so don't forget that when objects are in contact with each other, there's air friction that you have to think about and surface friction. And in addition, friction is always going to turn into heat every time. Friction will always turn into heat. Oh, I lost it. And thank you, that's about it. I thought of one more energy form. You can also have, sometimes you will have energy just transfer into a different form, like this chemical is giving off heat in your body and it's turning into mechanical. This mechanical is a turbine that has a magnet spinning inside of an electromagnetic field by copper wires. And that electricity, that mechanical energy is creating electricity as well. So sometimes you can have your kinetic turn into electrical, and you can have your electrical turn into heat. This goes back again with the conservation of mass, or conservation of energy, which is super important. The energy is always conserved. It only changes forms. It can't just disappear. It always has to go into a different form.